Well, the last time we were together, we talked about the three primary colors of light. And colors of light are called additive colors because we add those colors together and we are able then to make white light, which is a combination of all of the colors of light. Now, what we see, the colors that we see, are the colors that are actually reflected off of an object. So as an example, if I have a red object, and I shine white light on it, that means that I have got red light and blue light and green light that are all shining on this object. But the object only reflects back the red light into my eyes because that's the color that I see, and it absorbs the blue light and the green light. Likewise, if you have a yellow object and you shine white light on it, remember white light is a combination of red, blue, and green. So if I shine the red, blue, and green on a yellow object, it's only going to reflect back the red and the green, and it's going to absorb the blue. I won't see it. So even if I shine blue light on it, I won't be able to see it because yellow objects don't reflect blue light. They only reflect red and green light because that's what we see. So therefore, what would happen if I shine red light on a red object? What color will it look like? Well, a red object is capable of reflecting red light. So if you shine red light on a red object, it's going to look red. What would happen if I shone a blue light on a red object? Well, if I shine a blue light on a red object, remember the only color that this is capable of reflecting is red. It's not capable of reflecting blue. So if I shine a blue light on a red object, I won't be able to see it at all. It's going to look like it's black if you're in a dark room when you're doing this. Similarly, if you're in a dark room and you shine a green light on a red object, that red object can't reflect green light. It can only reflect red. And if you don't shine any red light on it, there's nothing for it to reflect. So if you shine a green light on a red object, it will look black because you won't be able to see it at all. Okay, now let's think about a yellow object. If I take a yellow object, I turn off all the lights, and I shine a red light on that object, what color do you think that object will look? Well, if I only shine a red light on it, it's capable of reflecting the red, but that's the only color that's there. So if you shine a red light on a yellow object, the yellow object's going to look red. Similarly, if you shine a green light on a yellow object, that yellow object can reflect the green light, but there's not any red light for it to reflect. So the only light that you're going to see is the green light that's reflected. So if you shine a red light on a yellow object, you see red. If you shine a green light on a yellow object, you're going to see green. How about if you shine a blue light on a yellow object? It can't reflect any blue light, can it? So therefore, if you shine a blue light on a yellow object, it will look black because this object isn't capable of reflecting any blue light. So therefore, when I start thinking about the color that objects are, most of those objects have some sort of a pigment in them to make them appear to be a certain color to our eyes. But the primary colors of pigments, we call those subtractive colors because what they do is they actually absorb some of the colors so that we can't see them, and they subtract those colors out of the white light. So here, the yellow is going to subtract out the blue, and it's only going to reflect the red and the green. So I actually have these, I have the yellow down here at the bottom. So if you have a yellow pigment, it reflects red and green, but it absorbs blue. Magenta, remember, if you remember how your colors of light mix together, magenta is made when you mix red and blue light together. So magenta reflects red and blue light, and that means it's going to absorb green. Something that is cyan in color will reflect blue and green light, but it will absorb red. So the three primary colors of pigment are magenta, cyan, and yellow. And I kind of alluded to that the other day when I mentioned your colors of ink. Your printer can take magenta, cyan, and yellow ink and make any color out of it by mixing these colors together. So what would happen then if I mix yellow and cyan and magenta all together? Now think about that for a second. The magenta is going to absorb all of the green light. The cyan is going to absorb all of the red light. The yellow is going to absorb all of the blue light. Well, by the time you've absorbed those three colors, there's nothing left. So therefore, magenta plus cyan plus yellow is going to make black. Okay? So let's think about what happens now if I start mixing some of these different colors of pigment together. Again, think about this in terms of paint. Think about it in terms of printer ink. So if your printer puts a magenta dot of ink on top of a cyan dot of ink, what are you going to see? Okay, well, think about it in terms of what each color reflects. So magenta reflects what two colors? Magenta is going to reflect red and blue. What colors does cyan reflect? Well, cyan is made up of blue and green. So that's the colors that it's going to reflect. So it's going to reflect blue and green. The cyan's going to absorb this red. The magenta is going to absorb this green, but the blue is present in both of these. So if I mix magenta and cyan together, it's going to look blue. So that's how your printer makes blue ink. It takes a magenta dot and puts it on top of a cyan dot. Okay, let's try another one like that. How about if I am trying to mix magenta and yellow? What color will I see if I put a magenta dot on top of a yellow dot? Okay, so magenta reflects what two colors? It reflects red and it reflects blue. Okay, what does yellow reflect? Well, yellow reflects red light and it reflects green light. So what two colors do both of those reflect? Well, the color that both of them reflect is red. The yellow will absorb the blue, the magenta is going to absorb the green, so the color that they both reflect is red. So if you want to make red, you have to mix magenta and yellow together. Okay, so we've got one more combination we can go through here. What if I mix cyan and yellow? Okay, so again, think about what colors are being reflected. What two colors does cyan reflect? Cyan is going to reflect blue and green. What two colors does yellow reflect? Yellow reflects red and green, because that's what makes yellow. So what color is reflected by both of them? The green is reflected by both of them. So if I put a cyan dot on top of a yellow dot, I will end up with a green dot. So as you can see, when I mix these primary colors together, so these are the primary colors of pigment, so the blue, the red, and the green are obtained by mixing the primary colors. So these then are going to be your, if I can spell that correctly, your secondary colors of pigment. And again, these are called subtractive colors because they are going to absorb certain wavelengths of light and they're going to reflect others. Okay? That may seem a little confusing at first, but you're going to get quite a bit of practice with it. So work on memorizing the color combinations first of all. If you don't already have the color combinations of your light memorized, that red plus green makes yellow, that red plus blue makes magenta, that blue plus green makes cyan, you need to memorize those for sure. And then once you have those memorized, then this starts to become easy because you can say, well, what does this reflect? What does this reflect? And what do they have in common?